The objective of this demonstration is to understand the lifting effect generated by the wingsuit of a skydiver. To begin the exercise, let's click Create Solution and select Fluid Behavior. Leave the fluid material set to air and allow Discovery Live to create a fluid volume for external flow. Then click Create. Zoom out and reorient the model to get a better look at the fluid enclosure, outlined in orange. We can click the ring outside of the orientation tool to rotate the model in the plane. For this exercise, we're going to assign the inlet face to the right side of the enclosure and the ground plane on the bottom. Once we've done that, Discovery Live begins to generate results. Let's pause the simulation and examine the results so far. If we reorient the model and look at it from the side, we can see that the skydiver is almost at the bottom of the enclosure. Since a real skydiver is surrounded entirely by air, we should move the enclosure to reflect this. We can access the Move tool from the Edit icon on the left side of the screen. Click Move and go to the structure tree at the top right side of the window to select the enclosure. Click the blue handle and drag it down until the skydiver is approximately in the center of the volume. To exit the Move tool, we can click the X in the icon at the top left of the window. Now let's adjust the boundary conditions. Increase the flow velocity from 10 meters per second to 53 meters per second. Let's reorient the model a little bit to check the slip symmetry condition. If we cursor over slip symmetry in the boundary conditions, we can see that the bottom face of the enclosure, which was originally defined as the ground plane, does not have slip symmetry applied. Right-click and select Edit Location to add this face. Rotate the model up a little bit, then hold Control and click the missing face. Once we're done, we can click the check mark at the top left of the window to complete the operation. Click anywhere in the background to deselect the enclosure. There's one last change we need to make here, but first let's reorient the model so we're looking at it from the side again. We can now hide the enclosure as well. So let's go back to the structure tree and clear the checkbox next to enclosure. Let's start the simulation again to see how the results look. As the designers and engineers performing these simulations, it's up to us to make sure that they're as realistic as possible. Otherwise, the results that we generate may not be accurate. Do you notice any problems with the skydiver in the current position and orientation? As you may have noticed, the airflow is traveling from right to left, when typically we'd expect the skydiver to be falling down. This skydiver is wearing a wingsuit, so we'll need to adjust his position accordingly. You can start the Move tool by pressing the letter M on the keyboard. Go to the structure tree again, and holding Control, select Skydiver and Wingsuit. You can reorient the model if necessary to get a better view. In this case, we're going to click the red drag handle, which controls rotation about this axis, and press the spacebar. Because we want to rotate the skydiver counterclockwise, which happens to be in the same direction that the arrow is pointing, the value we're going to enter in is going to be positive. In this case, we'll use 20 degrees and press Enter. Now we can see that the position of the skydiver has been adjusted. Press the letter S on the keyboard to activate the selection tool, and click your mouse in the background to deselect the skydiver and wingsuit. Now let's go back to our side view and examine our results. If we rotate the model slightly and zoom in, we'll notice that the flow is still passing through this wingsuit. As we've learned in a previous video, there are some models where it will be necessary to increase the fidelity to get more accurate results. Thin bodies in Discovery Live typically require a higher fidelity setting, so let's increase that now. Click to expand the simulation options and drag the fidelity setting about halfway and release it. As we can see, there's still room for improvement. Before we increase the fidelity to the maximum value, let's zoom out and check the enclosure. The overall size of the enclosure will also play a role in the accuracy of the results. A larger enclosure uses more of your computer's resources, so one way to improve the accuracy of the simulation is to reduce the size of the enclosure. Right-click in the background and select Edit Enclosure. Select the back face of the enclosure and use the Pull tool to reduce the size. We can do the same with the faces on either side of the skydiver. Click one face, then hold Control and select the other. You can roll the middle mouse wheel to query select if an object is obstructed by something in front of it. If you've set your options to zoom with the mouse wheel, you'll have to hold Control and then roll the mouse wheel. Once the desired object is highlighted, left-click the mouse to select it. With both faces selected, click and drag the Pull tool to alter them simultaneously. Click the X at the top left of the screen or press Escape on your keyboard to exit the tool. Now let's examine our skydiver again. Let's go back to the home view by pressing H on the keyboard. We can hide the enclosure at this point to get a better view of the results. We'll zoom out a little bit so we can see the entire Skydiver. To double check the accuracy of the results, let's select the cut plane and right-click and select Clip with Plane, then click Clip. This will slice the model in half along the cut plane, and if we reorient the view and zoom in, we can see how Discovery Live is treating this geometry. As we can see, there are still some small gaps in the geometry being used by the simulation, so we may need to increase the fidelity further. At about 3/4 of the way, the gaps are almost gone, but let's set it to the maximum value. This looks much better, and we don't see any flow passing through the wingsuit. Let's zoom back out. We can right-click and disable the cut plane clipping using the same option. Now let's examine the pressure contours on the Skydiver and wingsuit. Change the results to display pressure and set the display style to inverse surface. If we rotate the model a bit and disable the cut plane, we can see that the back of the Skydiver has low pressure areas, while the front of the Skydiver is where the high pressure flow is. This is exactly what we'd expect if the Skydiver is falling forward towards the ground. Let's look at the velocity again, but in a composite display. As we learned in a previous video, we can adjust the values of the velocity which are being shown. So let's go to the lower end of our legend scale so we can see the flow around the Skydiver, rather than the fast-moving air towards the outer edges of the boundary. The home view in this model will give us a good idea of how the flow is behaving as it passes the Skydiver. To get an idea of how much lift is being generated, we can define a calculator. The calculators can be accessed from this icon in the simulation menu above the boundary conditions. Click Calculator and give your calculator a name. In this case, we'll call it Lift. It's important to define the next option accurately. Here we select which direction the force is going to be reported in. If we choose this incorrectly, our results will be way off. A good reminder of what direction you want to choose is the orientation tool at the bottom left of the screen. We can see that Z is roughly pointing up relative to the direction the Skydiver is falling, so we'll select Z from the menu here. The last option allows us to define the location type. We can select a single face or all faces of the body. Choose all faces of the body and leave this selection set to chart. Then click Select. Click and drag a box around the entire Skydiver and wingsuit. Then click the check mark to accept that selection. As we can see, the calculator is automatically created and begins plotting the value. This value will fluctuate over time because the flow simulation is always moving, but it will always fluctuate about an average value. If we collapse the calculator using the arrow icon in the top left, we can display it as just a single numerical value. This makes it a little bit easier to read. If you'd like the result to remain closer to the average, we can activate the time averaging option in the simulation options. This icon here controls time average result display. Time averaging will smooth out the results over a period of time. If we expand the graph and activate time averaging, we'll see that the value begins to level out. Because we have the fidelity set to maximum, this may take a little while. Let's disable time averaging, collapse the graph again, and take a look at what the value is for the lift if the Skydiver does not have a wingsuit. Go to the structure tree again and clear the checkbox next to wingsuit. Our simulation will start over, calculating the values for the Skydiver as if he never had a wingsuit on. With the wingsuit disabled, we can also decrease the fidelity to speed up the simulation. As we can see, the lift generated by the Skydiver without a wingsuit is much lower. This concludes the demonstration on understanding the lifting effect generated by the wingsuit of a Skydiver.